all welcome on today's video, which will be talking about trigonometry. My advice to all the people who have started watching this video is that watch the video from the beginning until the end, because you will understand more if you watch the video from the beginning until the end. So for today's video, we'll be looking at what we call trigonometry, and this will be just a summary of trigonometry. So before we go into detail, the first thing that we look at, it is what we call the angles. Now the angles are divided into two. We have what we call radians angles and also degree angles. So we have radians and also degrees. So in this situation, what you need to understand, or the things that makes them to be different, it is that the units which are radians, most of the time they're represented in the form of what we call 2 pi, equal to the degrees are in which we say 360. So what we're just trying to say here is that when we move from this point, go like that, this is the whole of this angle, it is 360. So that's why you see 360 like that, right? Or in radians, it is what we call what? 2 pi. And this is just the ratio of the two. So you can say 2 pi is equal to 360 or pi is equal to 180. So this tells us that whenever you have a pi, it is just the same as 180 degrees. Okay, so the other part that you really need to take note of is this part. When the angles are in degrees, then you want to convert them to radians. So the formula that we use, it is the angle itself here, which is in what? Degrees. You multiply it with pi over 180 like that. Then you find your what? You answer the other side. So this is how we convert it from degrees to radians. But when it comes to this side, where you want to convert it from radians to degrees, so what you do, you're going to say theta, that is in radians, you multiply it with 180 over pi. So this is in radians, then 180 over what? Pi. But when it is in degrees, you're converting it to radians, this is what you do. So in short, when you want to convert it to radians, you need to put the pi on top, because the pi, it is more like a significant when it comes to what? Radians. But when it comes to degrees, you need to put 180 on top. So the questions, they may come like this sometimes. They can say convert the following. Convert the following to radians. So the first question, you have been given something like first question you have been given like 60 degrees like that. So you want to convert this one to radians. As I said, that when the angle it is in degrees and you want to convert them in radians, we say we put pi on top, 1 over 80. Like that, you're going to say 60 times pi over 180. Then what next? I'll say 60 times pi, it will be 60 pi over 180. So this 0 and this 0, they'll cancel. Then we have 6 pi over 18. Now, after having that, this means that you're going to say 6 into 18. It will be pi over 3. So that is how you answer this kind of the what? Question. Now imagine that you have been given another angle like -50, -150 degrees. So in this situation, you also do the same thing. You're going to say theta times pi over 180. Then you're going to say -150 times pi over 180, like that. Then it will be -150 pi over 180. So this and this, they'll go. Then you have 15 pi over 18. Then we look at for the numbers that can enter into both. So you shall see that if I say 3 into 15, it will be 5 pi. Then 3 into 18, it will be 6. So that is how you answer this kind of the what? Question. Okay. Right? So this is how you answer this kind of the question. If they ask you again the second time, like, okay, can you kindly answer this one? If they are given you, they have given you now, they have given you, that's 3, they have given you now 270 degrees. Then you need to convert this 270 to radians. So you're going to say 270 times pi over 180. This and this, they'll cancel. You're going to have 27 pi over 180. So what number that can enter there? It is 3. So it will be 3 into 27, it is 9. Then 3 into 18, it is 6. So you can reduce still 3 into that, it is 3 pi over 3 into that is what? 2. So you can't simplify this further. This means that that is your what? Your answer, just like that. Okay. Now look, if you have also been given another question, which is, we say convert the following into degrees. So you have been given this one. We are looking for these, convert these ones into degrees. The question is, what do we do when you have this kind of the question? So the first question, they'll say pi over 6. It is in radians, right? So when you're converting it to degrees, you're coming from radians, converting to degrees, you're going to say theta, that is in radians, times 180 degree over pi. So this part where there is theta, I'll replace this part with the angle that I've been given, which is in this angle there. I'll do that. Then this pi and this pi, they will divide. Then I'll have 180 over 6. Then I'll divide 6 into that, it is 3, which is what? 30. So that is how you answer that kind of the question. Okay, sometimes you may also be given something like this, 2 pi over 3. So in that situation, it will be 2 pi over 3 times 180 over pi. So this and this, they will divide. I'll have 3 of 2 over 3 times 180. So I'm going to say 3 into 180, it is what? 60. Then when I multiply, the answer to be 120. So that is how you answer this kind of the what? Question. Okay, now let's also look into another subtopic. Another subtopic, which is what we call this is the most important part of the trigonometry, which we call trigonometric function. So these are what we call trigonometry functions, or I'll call these ones again what we call the ratios. So these are the main important things that you need what to take note of: trigonometry functions or trigonometry ratios. So they can be functions or what we call ratios. So in this topic, the main thing that you need to take note of, we'll be dealing with what we call the angles and the triangles. Is it okay? So in here we have what we call SOH-CAH-TOA, SOH-CAH-TOA. But the angle that will be, the triangle that you'll be more familiar with, it is what we call the right angled what? Triangle. So that is a triangle that will be more familiar with. Okay, now SOH-CAH-TOA. So when it comes to SOH-CAH-TOA, you need to understand that we have sine. That's the first ratio. The second ratio, it will have what we call cos. The third ratio, you have what we call tan. So these are the ratios that you really need to take note of when it comes to this. Okay, so when you look at that, you have SOH. Let me start with it. SOH, right? So if you see you have so this is sine I, so it means sine theta is equal to opposite over hypotenuse, right? Then you have also what we call cos. So when it comes to cos theta, it is just the same as what? Adjacent over hypotenuse. Then when it comes to what we call tan theta, it is opposite over hypotenuse, like that, right? So these are the main ratios or functions when it comes to trigonometry, right? Now when it comes to the triangle, if we are on this angle here, let's look at this. If you are on this angle here, this will tell us that the side which is opposite to this angle, it is what we call the opposite, right? And the one which is opposite to the 90 degrees, it is what we call hypotenuse. Is it okay? So it's what we call hypotenuse. Then the one which is below the angle on what we are looking for, it is what we call the adjacent. So we have opposite, adjacent, and also hypo. So when you see sine, it is the side, each side it is what? Opposite hypotenuse. When you see cos, each side is what? Adjacent, which is this one, over hypotenuse. Then when you talk about tan, it is the opposite and the hypotenuse. So these are the main things that you need to take note of. Okay, now let's go to another thing which is more important than this one, right? We're still under what we call the ratios, right? So since we are still under what we call the ratios, on the same ratios, you have what we call basic identities. Basic identities. So when it comes to basic identities, these ones, they are also what we call reciprocal functions. So I can say reciprocal. This is reciprocal functions. So we can say reciprocal functions or basic identities. So the main ones that you need to take note of, you have what we call cosec. theta. Then we have also what we call sec theta. So these are the most important things when it comes to this. So we have cosec, sec, and also what we call cot theta. So if I say cosec, I mean its reciprocal, it is 1 over sine theta. Then again its reciprocal here, it is 1 over cos theta. Then its reciprocal here again, it is 1 over tan theta. Now remember, these are just what we call the basic identities, or what we call the reciprocals. Is it okay? I want you guys to remember that we were doing about what we call SOH-CAH-TOA, right? SOH-CAH-TOA, this word SOH-CAH-TOA. So you have what we call sine theta is equal to opposite over hypotenuse. Then cos theta is what? Cos theta is adjacent over hypotenuse. Then we have also what we call tan theta. Tan theta, it is what? Opposite over adjacent. So in this situation, if I say what are the ratios of cosec theta, it is just the same sign, right? You have seen the sign, which is here. So what I'll do is that I'll get the hypotenuse, I'll put it on top, then I'll get the opposite, I'll also put it what? Down. So what will be happening, what the ratios of cosec will be hypotenuse over opposite, like that. Then when it comes to the ratios of sec, look at the adjacent. So adjacent, it is there. Look at the cos. The cos is what? Adjacent over hypotenuse. So I'll get the adjacent will come the denominator, and the hypotenuse will come the what? The numerator. So in this situation, I'm going to say hypotenuse over the adjacent. So that is also the ratio that you need what? To take note of. And the other one that you need to take note of, it's cot. What are the ratios of tan? The ratio of tan is opposite over adjacent. So meaning I have to start adjacent over hypotenuse. So this is how you need to take note of when it comes to that. Okay guys, now let's go to the other important thing that we really need to take note of. Then the other important thing that we need to take note of are what we call spatial angles. Remember, the angles are divided into two. We had the radians angles and also the degree angles. Now let's go to what we call the spatial angles. Spatial angles. Okay, so the spatial angles that we need to know, or that we're supposed to know in mathematics, right? The first one, let's use the degrees. We have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and also 360. So these are the special angles that we need to know, right? So these are the main special angles that we really need to know. But the only ones that I'm very much interested at it, there are just 5 of these. So the main one, it is 0, 30, 45, 60, and 90. These, the first 5, that the special angles that make the rest that you see here. So these are the only angles that I'm very much interested at them, right? Okay, since I'm just interested at 5 special angles, meaning that we'll just learn about 5 special angles. That's the ones that we'll start with and we'll end with on this topic, right? Okay, now on these special angles, which are only 5, I'll say 5 special angles. So when it comes to 5 special angles, 0, 30, 45, 60, and 90. So on these ones, the first thing that we do, let's make a table for these, our special angles. Table of these, our special angles. So this is the table that we're making for our special angles, which is only 5 special angles, right? So this is what we shall do here, like that. Okay, let me use some space so that we can have more space. Okay, like that. So the first one, let's start. So with the first thing that you do here, you put sine theta. Then the next thing that you put, we put cos theta. And the other thing that we put tan theta. So that is it, right? So remember, we have 0, then we have 30, then we have 45, then we have 60, then you have 90, right? So it is very much important for you to know how to convert these ones. Now remember, these are degrees, eh? So it's very good for you to know these special angles in also radians. So let me put, this is radians, degree. This is pi over 6, and this is pi over 4. Then this is pi over 3. Then this is pi over 2. So these are the special angles, but they're in what? Radians. Is it okay? Now let's look at something here. We start to make these things, right? So we have some steps that we follow when we are making this table. The first step is, I'll say steps. The first step is count from 0 to 4. Let's count. I'll start from here. This is 1. My 2. Oh, from, I'll say 0, right? 0, 1, 2, 3, then what? 4. Okay, that is the first step. And the second step is put the square root. So this is the square root on each digit, the one that we have counted. So we put the square root. So if I may ask, what is the square root of 0? It is 0. What is the square root of 1? It is 1. What is the square root of 2? It is the square root of 2. What's square root of 3? It is 3, just like that. Then the other one, you say, what's square root of this? The answer is what? 2. So I'll start dividing everything. So the third step, divide every digit with what? With 2. So I'll divide here again, I'll divide here again, I'll divide. So if I say 0 divided by 2, the answer is what? 0. Let me just do it 0 like that, right? So 2 divided by 2, the answer is 1. Now remember that we counted from this side 0, 1, 2, 3, then 4. Now we start counting from this side. You're going to say 0, 1, 2, 3, then what? 4. So what I'll do, I'll go to the next step, put the square root on each number. I'll put the square root, I'll put the square root, I'll put the square root. The square root of 1 is 1, right? What's the square root of this? Is 2. So I'll divide by 2. The answer is what? 1. I'll divide this by 2. I'll also divide this by 2. I'll also divide this by 2. So when I divide 0 divided by 2, the answer is what? 0. Okay, now the next step, for me now to find tan, I'm going to get the upper point divided by the lower point. So the upper point, which is 0. So I'll say 0 divided by 1. What's the answer? It's 0. So meaning here it is what? 0. Then the upper point, what's the upper point? It's 1 over 2 divided by root of 3 over 2. Then it will be 1 over 2 times 2 over root of 3. This part and this part will go, so my answer will be 1 over root of 3. So it is 1 over root of 3. Now if you see this part divided by this part, the answer there to be what? 1, because this part, the upper part and the lower part, they are the same. So meaning the answer there is what? 1. But when you look at that part, root of 3 divided by 2 divided by 1 over 2. So you have something like root of 3 over 2 times 2 over 1. So this and that to go, then I'll have root of 3. So this is the root of 3. Then when I divide 1 divided by 0, that is undefined. So you leave out this box. In short, we don't have tan 90. That's what it's simplifying here. Okay, now this is the most important box that you require to know when it comes to what we call 5 special angles. So these are the most important special angles that you require you to take note of. Okay, now let's go to the other point, which is being referred to as what we call the interference or references. Is it okay? So I'll say references or references. Is it okay? Angles. So this is what we call references angles. So when it comes to the references angles, so these are just the angles that we use on the table, on this table. So all of these angles that we have used, this is 0, 30, 45, 60, 90. They are also called references. Why are they references? Because they are the ones that will be indicating if you have been given the angle that is very bigger than from these ones. So meaning that we'll be using the same ones to find the exact what? Values. Okay, now let's look at how we calculate the references. So if the angle it is from 0 to 90, we leave the way it is. But if it's from 90 to 180, in here for us to calculate the reference angle, you're going to say 180 minus theta. But again, the other one, if the angle is between 180 and 270, the way you calculate the reference angle, it will be theta minus 180. How about in this situation? It is also the same. So in here it is 270 to 360. So in here you say 360 minus the theta. So that is how you calculate the reference angles. So e.g., if you have been given the angle 240, now you look out, where is this angle belong, or which quadrant is this angle under? So you shall see that it is under 180 and 270. So how do we find the reference angle in this part? It is theta minus 180. So it will be 240 minus 180. Then the answer there will be 60, like that. You have seen how you calculate. So this angle that I've found here, it is what we call the reference what? Angle. Okay. And the other part, e.g., you have been given 315. Which quadrant is this one? It is under 270 and 360. So what do we do for us to find the reference angle? There we say 360 minus theta. So it will be 360 minus 315. So when you subtract there, the answer is what? 45. So this is the reference angle that is there. So that is how you calculate the reference angles. Now we need also to take note of on this part, when is sign positive and when is sign negative, when is tan positive and when is tan negative. We need to know that, right? 0 to 90 to 180 to 270 and 360. So here we say in the first quadrant, so we have the first quadrant. So this is the first quadrant. First quadrant, then the second quadrant, the third quadrant, and also the fourth quadrant. In the first quadrant, we say, oh, student, take coffee. But for me, I say cocaine. All students take cocaine, right? So here, all the angles that are positive start with sine is positive, cos is positive, tan is also positive. Even the reciprocal of cos, or the reciprocal of sine, which is cosec, is also what? Positive. The reciprocal of cos, which is sec, is also positive. Here, the reciprocal of tan, which is cot, is also positive. What is only positive here? It is just sine. And what? Cosec. But the rest are what? Negative. The only thing that is positive here, it is tan. So tan is positive and cot is also positive. The rest are what? Negative. And here again is the same thing. What is negative? What is positive? Only cos. But the rest are what? Negative. And the other one, it is sec. And the rest are what? Negatives. So those are the main things that you need what? To take note of when it comes to that. But how do the question comes? Let's do a bit of the examples on how the question may come on, or how they can ask you the questions, right? So in here, they can ask you the questions in so many ways. Is it okay? Now let's look at how they can ask you the questions. So the first, these are the examples. Here we see. So they can say sine, that's the first one. Sine what? Squared, which is 45. plus, let me do this so that you can see the question. They can ask you in this way. They can say, find the exact values of the following, right? So the first one, they can say maybe sine squared 45 plus cos squared 60. Then the other one, they can say 1 plus tan, this is number 2. 1 plus, that is tan 45 over, let me just do this. It's supposed to be we are supposed to subtract there, minus 1 plus tan squared 45, then plus C or sine squared what? 60, like that. So you have been given this kind of the question. What do? We need to go together with this table. So this table, it is very important when it comes to that. Remember that in that question we have sine 45. Now the question is, what is sine 45? So say sine, this is sine, right? Then where is 45? It's here. What is the answer? Root of 2 over 2. So meaning sine 45, it is root of what? 2 over 2. Now look, it is squared here, so it will be squared plus, what about this one? What is sine? What is cos 60? You do the same thing, cos 60. What's the answer? Half. So there the answer is what? Half, like that. So what is half? 1 over 2 squared, right? So if I square that, so root of 2 times root of 2, the answer is what? 2. Or in simpler words, if I say root of 2 times root of 2, you say 2 times 2, the answer is what? 4. Then what's the answer? 2. Like that. This is what I have what? Done here. Okay. Now, how about 2 times 2? 4 plus. When you square that, it is 1 over what? 4. What is the common denominator? It is 4. So we need to be 2 plus 1. Then the answer is what? 3 over 4. That is how you answer that question. So if you look at this one, this is 1 minus, right? So if you look at this, let's put 60 here. Sorry for that. Let's put 60 there. Put 60 there. Is it okay? So what is tan? So remember that you have 1 minus. So what is tan 60? Tan 60, the answer is what? Root of 3. So you also do the same. So meaning that there it is root of 3 squared over 1 plus, what is tan 60? Again, root of 3. So you square plus. When you look at this part, what is sine 60? So sine 60, it is root of 3 over 2. Now it is squared, so it is squared. So you have to say 1 minus. When you square that, what's the answer? It is 3 over 1 plus 3 plus. What will be the answer? It will be 3 over 4. But here, what is the answer? It is negative 2 over 4 plus 3 over 2. Or plus 3 over 4. And what is the common denominator? It is 4. Then 4 into that, it is 1 times that, negative 1. Then 4 into that, it is 1 times that, it is 3. Then your answer is 1 over what? 4. Simple and straightforward. forward. So that is how you answer that kind of the what question. Now, you may not be been given something like that every time. No. Sometimes you may be asked in this way. They can say evaluate the following. Let me say the following. Evaluate the what? The following. The first one, it is sine 210, right? And the other one, it is cos 405. So in this situation, we do this. The coordinates, the one that you had, right? What is sine 210? That's the first question that you need to ask. What is sine 210? Now we don't have sine 210. And where is 210 is exactly? It is in which quadrant exactly? It is in third quadrant, because this is 180 and what? 270. So it is in the third quadrant. How do we calculate the reference angle there? We say theta minus what? 180. So I'm going to say sine 210 minus 180. Now, if I may ask, is sine positive in third quadrant? It is negative. So it will be negative sine there. What will be the answer there? So say 210 minus 180. What is be the answer? The answer will be 30. What is sine 30? Which is half. Like that. That's the same thing that you do. Now, this one, it is above what? 360. So if it's above 360, what do you do? Say 405 minus 360. So you shall find that the answer is what? It is 45. And what is cos 45? Root of 2 over 2. So that is how you answer that kind of the questions. Okay, now let's look at the other interesting part. On the same ratios, this is just the ratios. They can ask you in this way. Find the values of the other 5 trigonometric functions. Is it okay? Now, the first one, it says you have been given sin theta is equal to 3 over 5. You have been given that theta is in the first quadrant. So you have been told that sin theta, or this angle, it is in the first what? Quadrant. So remember that in the first quadrant, everything is positive, like that. And what you have been given? You have been given sine. So we do what we call SOH-CAH-TOA, like that, eh? What is sine? Sine, it is opposite over hypotenuse. What is the opposite in this situation? The opposite in this situation, it is 3. So 3, then hypotenuse is what? 5. What are we remaining with? We are remaining with to find this, because this is our angle, right? So how do we use this one? We use what we call Pythagoras what? Theorem. So Pythagoras theorem states that hypotenuse is the longest distance side. So it will be a squared is equal to b squared plus c squared. So what is a in this situation? The a in this situation is 5. Then you square it. Then b, it is 3. Then we are calculating what? C. So you have, what's the answer there in this situation? It's 25 is equal to 9 plus c squared. Then 25 minus 9 is equal to c squared. Then what is the answer in this situation? It will be 16c. Then you put a square root, then your answer there is what? 4. So c, it is what? 4. Now they have asked you to calculate how many? 5 functions. So the first one, what is the reciprocal of sine? So reciprocal of sine, it is cosec. We'll just swap its side. So that 5 will come the numerator and 3 will come the denominator. So you have 5 over 3. Then the second one, it is cos. Cos, it is adjacent over hypotenuse. So what's adjacent? It is 4 divided by what? 5. So it will be 4 over 5. And what is the reciprocal of cos? It is sec. So meaning it will be 5 over 4. Right? Then you go to tan. When it comes to tan, it is opposite over hypotenuse. So it is 3 over 4. Then you do the rest, which is cot theta. So to what? 4 over 3. So how many are these? There are 5, which they are what? Asking for. So that is how you answer this kind of the what? Question. Right? So that's how you answer this kind of the what? Question. Now, look, just imagine that you have been given there another one, which is like this. You have been given the another one, which is like this. Okay. And then the second question, you may be given it in this way. They can say cos theta is equal to negative 12 over 13. Then the theta is in the second quadrant. Is it okay? So it is in the second what? Quadrant. So what do? You do the same thing. The main important thing, you draw, because if you don't draw, it will be very hard for you to answer that question 9. So it's better you draw. So in that situation, you are going to say this is second quadrant, right? Now SOH-CAH-TOA, it's more important you write SOH-CAH-TOA like that. So what is SOH-CAH-TOA? What is cos? Cos theta is what? Adjacent over what? Hypotenuse. So in here, what is your adjacent? So if this is your theta, what is your adjacent in this situation? It is 12. So say 12. And what is hypotenuse? 13, the down one. So here it is negative. Because why is it negative? Because the x-axis there, it's what? Negative. So meaning that this side it is negative because the x-axis is what? Negative. That's why I've said it's what? Negative. Okay. I need to find the opposite. How I'm going to find the opposite? By using the same method. What is hypotenuse? 13 is equal to, what is b? Negative 12 u squared plus c. So you shall see that if I say 13 squared, the answer that I'll get is 169, right? 169 is equal to 144 plus c. So you shall have 169 minus 144 equal to c squared. So 169 minus 144, the answer is 25. So you say 25 is equal to that. You put the square root, you put the square root. So what is your c? It is 5. So that is your c, which is what? 5. Then after doing that, what is the next stage now? You start. When you look at cos, its reciprocal is what? It is sec. So you just swap the two. 13 over 12. Then you go to sine. Sine, it is opposite over hypotenuse, which is 5 over 13. Then cosec, which is its reciprocal, it is 13 over 5. Then when it comes to tan, which is opposite over adjacent, so opposite adjacent, so it is negative 5 over 12. Then 5, it is cot. Cot, it is negative 12 over 5. So that is how we find this. Okay, so that's how you do with these simple things, just like that, just like that. Okay, on the next video, which is part 2, we'll look into the trigonometric identities and also the graphs. So that is the next video, which is part 2. Make sure you subscribe and also you comment where it is necessary.